Hello, I am Zalalam. Today we will discuss how to design algorithms using various
But
tools.
first, please prescribe using the red button on the right lower side of the video.
What is an algorithm? An algorithm is any well-defined computational procedure or process that takes input as value or multiple of values or sets of values and produces an output. And the output can be a single value or a set of values, and in each step in the algorithm we have to be sure that it is unambiguous and clear so that it won't be interpreted in different ways by different observers. It should always have the same meaning, and always we should not use computer code when we design algorithms. Computer code is supposed to be used during implementation of the algorithm, and your algorithm is said to be correct if for every input instance it halts or stops with a correct output. That means for every valid input it should produce every time valid output. What are the tools we use to design algorithms? The commonest two tools that we use um, to design algorithms are flowchart and pseudocode. Today we will discuss about using flowchart, and we will discuss about using pseudocode in another video. Um, Before we see an example on using flowchart, what is flowchart? So a flowchart is a tool designed by using a set of shapes and symbols um, to show a step in an algorithm. And these shapes and symbols are an agreed upon symbols, whereby each symbol has a specific meaning. There are lots of symbols, but we will see the commonest types of symbols. For example, this round corner rectangle is a symbol used to indicate the start or the end of an algorithm, and when we use a parallelogram, it indicates either there is an input or an output in the algorithm process. And uh, a sharp cornered rectangle shows a process. When we say a process in an algorithm or a flowchart, there is something going on um, that happens to the inputs of the algorithm. For example, if we are doing uh, an algorithm that involves division, the action of dividing one number by another is said to be a process. And the other is a diamond. A diamond shows a decision. When we say a decision, the outcome of the process might be either true or false, or sometimes it might have more than two outputs. For example, if we are providing um, lettered grades to grades, we might have um, outputs based on the grade that a student has. For example, if it's less than 50, less than 60, less than 70, and so on. Depending on that one, we decide what letter grade we are going to get. Or if it has two outputs, when it's true, we'll go to one process or flow. If it's false, we'll go to the other process or flow of the flowchart or algorithm. The other is a connector, which is a circle. It connects two algorithms within a page, or two processes that has to combine within a page. And if we need to connect algorithms across pages, then we will use this inverted pentagon sign to connect algorithms in two different pages. Now let's do our example. Let's take the example that given two positive integers m and n, we will find their greatest common divisor. So that means the largest positive integer that can evenly divide both m and n. This is called their greater common divisor. So we will start by the rounded corner rectangle, where we see the starting point of the flowchart or algorithm. Then we will go to the next step, whereby we will collect our inputs. So we will collect our inputs m and n from the user or from other process. And after collecting the inputs, we will go to the next step of dividing m by n. So this is a process. So it's indicated by a sharp cornered rectangle. So when we divide m by n, if there is a remainder, we will assign it to r. Always there will be a remainder, either it's 0 or greater than 0. So that's why we used diamond to decide whether the remainder is 0 or greater than 0. If the remainder is greater than 0, we will do another process, whereby we assign the value of n to m and the value of the remainder to n. Then after we assign these values, we will go back to the process of dividing m by n. And as long as the remainder is greater than 0, we will circle through this flowcharts. Okay? We will assign the remainder, then we will go back to the process of dividing m by n. As long as the remainder is greater than 0, we will continue to go through this cycle. Then once the remainder is 0, we will go to the output of returning n. That means if n divides m without a remainder, that means n is the greatest divisor of both m and n. If n divides m without a remainder, then we know that n divides n without a remainder. So we will stop by returning this greatest common divisor of both m and n. And we will show our end of the flowchart or algorithm by the rounded corner rectangle. So this all indicates how we can use these tools to design algorithms before we go to implementing our algorithm using computer programming language of our preference. So this is not specific to any programming language. We design it and we can implement it using any programming language. I hope this helps in using flowcharts to design algorithms. Thank you for your time.